Alright everyone, so today will be our lesson 7, which is the last part for our statistic chapter 1, which is representation of data. So today we are going to cover 3 learning outcome, but don't worry, it's going to be like a little bit more easier than the previous lesson that we have, because it's not much on calculation. It's basically on how do you represent data using diagram or using a graphical approach. So there are 4 main things that we are going to learn today, which is how to draw a stem and leaf diagram, how to draw a box and whisker plot, histogram, and cumulative frequency graph. Then after that, with all these 4, then you are going to but this one will be not so applicable for your exam. That normally in the exam they will give you exactly like what is the type of graph that you need to draw, but you must know that for this kind of graph, normally we use for which type of diagram, which type of data, and then what is the advantage of it, what is the disadvantage of it. Then after that, we are going to learn how to use the cumulative frequency to estimate or to identify what is your median, what is your quartiles, then how to find the proportion, whether it's below some specific number or above some specific number. Okay, so for today it's going to be quite chill, and I think the homework will be lesser also, because this part is actually not so much focus in your exam. It's basically about drawing graph. Okay, so yeah, first of all, let's try to go through this first. So as we discussed before, that we have 2 types of data in statistics. So you have qualitative, which is categorical data, and then you have quantitative data, which is numerical data. So for today, we are going to focus on this part. So meaning that we are looking at how do you group, how do you represent your quantitative data in a graphical way. Okay, so we are going to learn 4 today, so which is the 4 that I have highlighted here, which is stem and leaf diagram. And for stem and leaf diagram, normally we use it for small amount of quantitative data. So stem and leaf diagram cannot represent continuous data. So meaning if you have a range of number, or your data has some decimal point, and if it's a large amount of data, then stem and leaf will not be a very good approach. Then normally for large amount of data, we use histogram and cumulative frequency graph. So you can see that box and whisker is not in the graph, because box and whisker plots is mainly on the measurement part. So don't worry, we are going to look at it later. Okay, so this is just an introduction for you, what happened for the whole thing for today. Okay, so let's start with the first one that we are going to learn. So the first one is going to be stem and leaf diagram. So you can read through by yourself. So I'm just going to go through it. Stem and leaf, basically we'll use it if our data is only a small quantity of our data. So because all your raw information you will need to show in the diagram itself, so it will be not so suitable if you have a large amount, because you need to arrange and then write all your data, and it's not going to be any analysis. It's just arranging your data. Okay, so but this stem and leaf diagram is going to help us in how if you want to compare a distribution, especially you have 2 main distribution that you want to compare, then stem and leaf will be a good approach. Okay, so you can read the notes by yourself. So I'm just going to go through the drawing, the technical part. Okay, so let's go to the first part. Okay, so the height of plants A are listed and above. Create a stem and leaf diagram based on the data. So yeah, so this is your number 1 example. So we are going to create a stem and leaf diagram together. Then after that, you can proceed with your own homework and so on. Okay, so the first one is actually going to be quite easy. So it's the same thing, you need to, so it's called stem and leaf. So meaning you need to identify yourself what is the stem that is suitable for this question. Okay, so by looking at this question, right, you can realize that you have 23 the minimum, then the maximum is 65. So the range or the interval, the size that will be suitable here, it is like a group of 10. So meaning like from 20 to 29, from 30 to 39, from 40 to 49, and so on. So now we can start to create our stem and leaf. So yeah. Okay, so the idea is actually quite easy. So for this one, because you can see the data here is already arranging in order. So if this data is not arranged in order, then make sure when you create your stem and leaf, you must make sure that your data is in order. Okay, so for this one, since like we have just a few of 10, like 2, 3, 4, 5, and 6, so that's why we can 2, 3, 4, 5, 6. Is that alright? I hope you can see, because I need to draw graph and so on. I realized that if I use the magic pen, then I will be like it will be very hard for me to draw. Okay, but I think you can see. Okay, so number 2. Okay, so this number here are called as stem. So meaning that the 10 part. So if your data is going to be have some decimal, then of course you can put your data like 2.3, then your stem is 2, then the decimal part will be your leaves. Okay, so this is stem, then your leaf will be what is the another number. So this is like the stem for like the 20. So you have 3, 23, 25, 29 here. So you can have 3, 5, 9. Okay, and then 3 you have 34, 37, 38. So 4, 7, 8. Okay, same thing go for 40, 41, 42, 46, 49. Okay, then 50, 52, 54, 54, 55, 7, 8, 9. Okay, then after that we have 60, so you have 3, 3, 5. Is that alright? Okay, so after you write down, then you must remember when you do stem and leaves diagram, you need to write the key. So the key will be something like this. So this is like to identify what is that mean by your leaves, what is that mean by your, what is that mean by your stem, what is that mean by your leaves. Because this, if I want to change it, then this can be like 2.3, 2.5, 2.9, or this can even be 0.29, 0.23, 0.34, and so on. So you need to tell the reader that reads your diagram to know that what is that mean by your leaves, your stem, what is that mean by your leaves. So for here, normally we will use the first example here, so which is 2, 3. So 2, 3. Okay, so 2, 3 here actually represent 23. Okay, it will be good if this question give you like, okay, maybe I write here. So maybe all of this height is actually measured in cm. So when you write this, then you will write represent 23 cm. Okay, so this is how do you do it usually. So if your data is 2.3 through 2.5, 2.9, then you are going to write 2/3 represent 2.3 cm. Okay, so for number B, I guess you can do it. So I'm just going to like write it here, then you can take your time to fill in your worksheet also. 2, 3. Okay, so when you finish it, don't forget to write down your key. So for here, it's going to be 2, 3 also. Okay, it's going to represent 23 cm. Is that alright? Okay, so don't forget your key. Okay, so the next one. Draw a back-to-back stem and leaf diagram to show this data in a single diagram. Okay, so for these two, right, they only show like this is the plant A, this is the plant B. So now back-to-back stem and leaf diagram, what is the difference between these two is that back-to-back stem and leaf diagram, you are going to compare. Normally we use it to compare two different set of data. Okay, so yeah, let's see how do we do this. Okay, so it's the same thing, but now we are going to have the two set of data combined. So we will put our stem in the middle. Okay, so you have take the here 2, 3, 4, 5, 6. Okay, then after that you write down for your first one is going to be, this is for plant A, right? So you write down here plant A. Then for here it's going to be plant B. Is that alright? Okay, then after that, what do you need to do is you need to write down your information from these two. So we start from plant A first. So when you write this, right, so you must remember the further the bigger the data, the further the distance. So meaning like if you have 2 here, so before that, because we start from left to right, but here is going to start from your middle. So for plant A is going to be right to left, then plant B is going to be left to right. Okay, so for the 2 here, you're going to be have 3, 5, 9. So 3, 5, 9. Is that okay? So the bigger the further away. So 4, 7, 8, 1, 2, 6, 9, 2, 4, 4, 5, 7, 8, 9, and then 3, 3, 5. Okay, so that's for your plant A. So now for plant B, we do the same thing. You can copy down the data here. 3, 5, 7, 7, 8, 2, 2, 4, 5, 8, 8, 9, 1, 4, 5, 5, 7, 2, 3, 5. Okay, is that alright? Yeah, I think you can roughly get the idea, right? Okay, so after that, what do you need to do? Yeah, same thing, you need to write down your key. So for the key here, because you have something like this, yeah, so okay, let's write here, or yeah, here. If you have space, you can write down here, okay? Okay, so your key now, because you are having left and right, so you need to explain for both. So meaning we will take 2, 3, 3 maybe. 3, 2, 3. Is that okay? So copy from here also. Sorry. Okay, this is going to be like the line, so it's like a straight one, okay? Yeah. It's not a slash thing. It's like a straight line. That is exactly this line now. Okay, so what is that mean by this? So 23. So actually this thing represent, okay, 23 cm for height of plant A. And then the other one, 23 cm for height of plants B. Okay, so this is how you write your key. So the same thing, so 1 like the 3 in front and 3 at the back, so copy like from the first set of data here. Okay, alright, so now compare the height of plant A and plant B. Okay, so when you look at this, I'm actually writing something down here. If you want to compare the distribution, you need to make the comparison in context, and normally you will make reference like you will compare in terms of average and the spread. Okay, so by looking at this is your plant A distribution, this is your plant B distribution. So what can you realize? We start first with the average value. Okay, so when you look at this value and when you look at this value, right, which plant actually having the higher plant? Like which one has the, like which plant is taller than each other? Okay, so you can see like this is basically the mode is like here, the mode is like here. So when you compare in average, then you can see that generally or like overall your plant A actually having a taller height if you compare to plant B. Okay, so the first thing that you will say is in general or like in average, so that's the word that we use. Okay, make the comparison in context, meaning that you use what is the thing that you are actually making comparison. So you don't say like X, Y. So this is like the height of plant A and plant B, then you will use plant A and plant B. Okay, so in average, plants A are taller than plants B. Okay, so the first thing that we can see. Okay, second one, we compare in terms of spread. So you can see here, the minimum is like 23, the maximum goes to like 65. But for plant B, the minimum is like 23 and the max is like here. So in terms of variation, actually plant A is widely spread compared to plant B. Okay, so the same thing that you can write. Okay, plants A has a wider range, or if you want to say wider spread or wider variation, is the same lah. Okay, compared to plants B. Okay, is that alright? Yeah, I guess it's quite easy, right? Yeah, something just to bear in mind is just that when you write the key, you must refer back to your question lah. So if you are doing something like 100 something, then your key might be like 1. Then okay, like this one, if it's like 2.3, then you are going to write 2.3 cm. It's just that you must remember to write down your key. Then the other one, I think it should be no problem for you. Okay, so that's the part 1 for stem and leaf diagram. Okay, so we continue with the second part, which is box and whisker diagram. Okay, so this diagram, it can be represent a large amount of data or small amount of data, both can be. But something that you need to bear in mind is like the box and whisker diagram, like they didn't use the raw data to come up with the graph. So the thing that they represent in the box and whisker diagram is the 5 number summaries, which is the 5 thing. You have minimum value, the first quartile, the median, the third quartile, and the maximum value. So from this is the box and whisker, then normally we will have a scale. It's just like how you draw a graph, then you need a scale. So after that, what is that? What is the feature that you use to draw? Then you will see. So the start and the end of your graph is going to be the minimum value and the maximum value. And after that, for your box, right, the starting of your box will be your lower quartile, and then you have the second line will be your median, and the last line will be your third quartile. Then you draw a box. So this is what is that called by box and whisker. Okay, so from the diagram, from this diagram, what you can see is this is like from 0 to 15 scale, right? So like every 4 box you get a 1. Okay, so from the diagram, what can you observe is that the median is like Q2 here. So what is the Q2 here? It's like a 6. Okay, so maximum value is 14. So the maximum value is here. Okay, sorry, maximum value is 14. Minimum value is going to be 1. I'm sorry, I will change in the notes that I give to you. Okay, this is 1. Minimum value is 1 here. And then what is your range? It's going to be like 14 minus 1. So this is how you get 13. Okay, so for your Q3, it will be here. So which this is represented by 14. And then Q1 is 4, which is here. Then your IQR, meaning interquartile range, will be your Q3 minus Q1, which gives you 7. Okay, So something special about box and whisker diagram is you can use box and whisper diagram to check outlier. So outlier is something like extreme data. So if like you have a set of data, okay, for example, when we talk about result, okay, so like if your max score in your class is like roughly range about, like most of the people is getting 70 and above, but there's one people like getting 30 plus, so this is like the outlier. Okay, so for box and whisker diagram, normally how do we count the outlier is that any data set which is more than 1.5 times the interquartile range, above the upper quartile or below the lower quartile, then it will be identified as outlier. So meaning these are the outlier. So like from here you get 7, right? So 7 times 1.5, then you use Q1 to minus, then you see what is the range that you can actually accept. Then out of the range, then it will be counted as outlier. Okay, so for this part we are going to do example later, but this formula you don't need to memorize, because if that is going to come up in your exam, I think it's going to be like just a few years that having this sort of question. But for that question, normally they will tell you what is outlier, because this is not something that is actually stated very clearly in your syllabus that you need to learn outlier. So it's like an extra thing. So if they ask you something like that, then normally they will give you the definition, then you can use the definition to find your answer. Okay, so the second thing about box and whisker diagram will be this, which is called skewness. Okay, so this is the term that used to describe the lack of symmetry in a distribution. Then okay, the lack of symmetry in distribution, what is that mean? So if you have a set of data, meaning, okay, for example, if I have a range from 1 to maybe 1 to 100. Okay, so maybe I have, for my mean is like 50, right? Then I have the other number, maybe I have 20 number that is like before 50. Then I have another 20 number that is like after 50. This is like 1 to 100. Okay, so this type of distribution, we'll call it as symmetric. So if this is like the median, the number that before my median and the number that after my median is like roughly same to each other. So that's why we'll call it as symmetrical. Okay, so this is represented by, so you can see your last graph here. So if you draw a box and whisker diagram, then it's going to be have the same equal tier, and then the size between your box is going to be like roughly the same also. So this is like the symmetry one. So meaning like the data that less than your median and the data more than your median, the number of it is like roughly the same. Okay, so the we look at the first one, that you have a positive skew distribution. What does that mean? Okay, positively skewed, right? Meaning that if you are having a median here, so if this is 100, then this is 100, and then this is 1. Okay, so what happened here is like if I have like 30 number actually above 50, and then I have only 10 number actually smaller than 50. So this is called as positive skew. So you can look at this, the range between your positive one is like very a very great distance. So like a long tail to the right, and then the number when your Q3 minus Q2, meaning the distance here will be greater than the distance here. So this is called positively skewed. So meaning like you have a larger, in short it will be like you have like more number that is over your median than the less than your median. Okay, so negatively skewed is the opposite of the positive one, meaning that for example if you have like 50 here, then this is 100, then this is 1. So you are having maybe 30 value actually below your median, and you have only 10 number above. So you can see there's like more less than more than. So that's why this is like negatively skewed. So you have a longer tail to the left, and then for the part where your Q3 minus Q1 will be less than, so like the distance here will be shorter than the distance there. Okay, so there's actually something called skewness coefficient that can help you to count, but the idea is, oh, I'm so sorry, just now you can't see this, right? Okay, yeah, by looking at it, so this is the symmetrical one, so meaning like the tier and the distance in the box is like roughly the same, so this is called symmetrical, so meaning like to less than your median or like more than your median is roughly the same. Okay, so yeah, just now go back to the thing that I said. So for skewness coefficient, so that is not inside your syllabus, so what is important is you need to identify like informally. So if they ask you to describe it, then you just say that it's whether a positively skewed or like negatively skewed. Okay, so now we look at some example to draw a box and whisker diagram, then we are going to like do some comparison also. Okay, alright, so the number of fouls made by 8 hockey matches and 8 football matches playing at a weekend are shown here with this is the back-to-back stem and leaf diagram. Okay, draw 2 box and whisker diagram using the same scale and then identify the outlier. Compare the number of the fouls committed in the 2 spots. Okay, so yeah, I hope you still remember how to read this, but oh, I think I left out. Okay, I will write down in your notes there also. So the key here is actually 1, 1, 0. So it's 11. Represent 11 fouls for hockey, and then 10 fouls for football. Okay, so draw 2 box and whisker diagram using the same scale. Identify the outlier if there is any. Okay, so you still remember what is the few things that you need if you want to draw a box and whisker diagram? You will need to find out your 5-number summary, which is your minimum point, first quartile, median, the third quartile, and the maximum value. Okay, so from here, there's like 8 number here and 8 number here. So we start from hockey. Okay, so what is the minimum value here? So you can see it's like 11, 12, 14, 16, 18, 19, 21, 24. So for the hockey, your minimum value here is actually 11. Okay, so for your, now is your first quartile, Q1. Okay, so what is your Q1? You have 8 number, right? So you still remember for first quartile, you use 8 you use 8 divided by 4. So you have 8 number. Then for first quartile is going to be 1/4 of your total observation. So that's why 8 divided by 2. 8 divided by 4, you are getting 2. So it's going to be the third, the second, the midpoint between your second and your third of your observation. So that's why 13. Okay, if you find it difficult, then what you can do is you can write down your number since you only have an 8 here. So meaning like 11, 12, then 14, 16, 18, 19, 21, 24. So if you need, you can write down also. Okay, then you can see this like more clearly that you have 8 number here. So that's why your median is here, your Q1 is here, and your Q3 is here. But if you're using the method that 8/2, 8/4, 8 times 3/4 is going to bring you to the same answer. Okay, so yeah, I'm not going to repeat that much on that because you should be able to do this already from the last lecture. Okay, so what's your median? So your median will be 70, your Q3 will be 20, and then your maximum value here is going to be 24. Okay, so the same thing, you do it for football. So if you need, then you can write everything out also. So your minimum value is 10, and then our Q1 is actually 18 plus 19 divided by 2, which brings you 18.5, and then your mean is going to be in between 19 and 21, so which gives you 20. Q3 22, between 22 and 23, so it's 22.5, and your maximum here is 23. Okay, I hope you have no problem with that. Okay, so now what can we try to do? We can try to draw already. So you must remember, start from your scale. So let's draw the one for hockey first maybe. Okay, so write down your scale. So since you have the minimum, like, so maybe we do a 10 to 25. So this is 10. Okay, so we can do like everything that you have 1, then 15, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is that okay? Yeah, you can try to draw together with me, like not just looking at a video. Okay, so now you have the scale already, then you can start to plot already. You can plot the 5 number first, then after that you know what to do. So 11, you can draw it like starting here. I think you have enough space. Okay, then 13 is going to be 1, 2, 3. Okay, then 17, 20, and then your end is 24. Okay, so you must remember you have tier at the back, but what you can try is you can try to draw your box first, which is your Q1 and your Q3. So here, your Q3 is here, your median. Okay, then you can start to draw your line. Oops. Okay, I hope you can get it. It's basically minimum point, maximum point, Q1, Q3, Q1, Q2, Q3. Okay? Alright, so we do the same thing now for badminton. For football. Okay, again you need to draw your scale. Okay, then you do the same thing, plot your 5 number. Okay, I think you are alright, so I don't need to explain. Everything is basically about drawing, so yeah. Okay, is that okay? Yeah. So when you look at this one, actually you will realize that for hockey it's going to be like, yeah, if you want to put a notes here, I mean, the question didn't ask you to do this, but yeah, if you want to write down some of the description, then this one will be actually, the data is actually quite symmetrical. It's like a symmetric distribution. So this one, So you can see like all your number is actually on the less than side. Yeah, so what you can realize here is that yes, it's going to be negatively skewed. Okay, so this is just for your information, like you do not need to write it down, it's totally fine. Okay, so negatively skewed, or sometimes we can say skewed to the left also, is totally fine. Okay, so the question asks you to identify the outlier if there is any. Okay, so how do you identify? Okay, so if you want to identify, then you must use this. Okay, then you check it out, what is the range that actually form the outlier first. Okay, so we start from the hockey. Okay, you can find out your IQR first. So your interquartile range for hockey is actually 20 minus 13, which is 7. Okay, so the range that is outside of these two range is considered as outlier. So that's why x lesser than Q1 minus 1.5 times your IQR. So your Q1 is 13 minus 1.5 times 7. Is that okay? 1.5 times your IQR. Or the other one will be x greater than Q3, which is 20, plus, again, 1.5 times 7. Okay, then you can get the answer. 13 minus 10.5, which will gives you 2.5. And then for the range upper there, then it will be x greater than 10.5, so 30.5. So any value, any data that is less than 2.5 or greater than 30.5 is considered as outlier. So you look at hockey, do you have any number that is less than 2.5 or any number that is greater than 30.5? You don't have. Okay, so for hockey, no outlier. Okay, so for the second one, then we look at football. Okay, so we do the same thing. IQR, use your Q3 to minus Q1, which will gives you 22.5 minus 18.5, which is a 4. I'll write down 22.5 minus 18.5, which is 4. Okay, x smaller than Q1, 18.5 minus 1.5 times your IQR, or x greater than Q3, 22.5 plus 1.5 times 4. Okay, which gives you minus 12.5, or x greater than 6, so 28.5. So any number that is smaller than 12.5 or any number that is greater than 22.5 is considered as outlier. So for this case, do you have any value? Yes. So you look at this one, the minimum that you can accept is actually 12.5. So but after that you have one value which is a 10. So for football you have actually one outlier which is 10. Okay, yeah, I'll try to give you more space here later. Okay, then after that, last one, compare the number of fouls committed in the two sport. Okay, so when you look at these two, right, so we talk about the same thing, two things here, the average and the spread itself. So we start from the average first. So when you compare the distribution that you have for hockey and the distribution that you have for football, so in average, which one is more fouls? So it's going to be like here, because for average, you can see that football actually commit more fouls than hockey. So you can say that in average, there are more fouls in football than in hockey. Okay, then after that, now we look at the spread. So you can see like this is like roughly the same way, but this one is like more negatively skewed. So this is like symmetry, but this is like the range is like higher than this one. So the number of goals, okay, the number of fouls in football are more. Yeah, you can use varied, or you want to use widely spread, also can. Are more widely spread than hockey. Okay, is that alright? Yeah, I hope you can like get the idea. I'm so sorry. Okay, so I put the oops. Okay, so in average, there are more fouls in football than in hockey. The number of fouls in football are more varied or like more widely spread than the hockey. Okay, because you see like the spread is like higher than the hockey itself. Okay, so that's the part for box and whisker. So next one, we'll move on to histogram. Okay, so next one, the third representation, we are going to look at histogram. Okay, so normally histogram, it can be used in represent even a discrete data also can, or like a continuous one also can. So there are actually, I would say it's like two types. It's basically the same thing. It's just like something that you need to be a little bit more cautious when you do the question. Okay, so you will have two cases that if the interval, so meaning the class interval, the interval size is the same, then the height of the bar, you can actually straight away use the frequency to do that. So if your interval are not of equal width, then you might need to change your frequency into frequency density. So how to do that is use frequency divided by interval width. So later we are going to look at these two examples, then you can try to understand the idea. Okay, so before that, I'm going to introduce a very short idea or a concept of limit and boundary. I'm not sure whether you learned this before, but I'm just going to repeat that. Okay, so for limit, right, normally the question will give you like given the class interval is like 1 to 5, 6 to 10, 11 to 15, and so on. So all this number like 1 to 5, 6 to 10, and so on, all the number here is actually called as lower limit. Okay, I'll write here LL maybe. Okay, so this is like the LL, LL, LL. Okay, so this is like the lower limit of the class. So meaning like for 1 to 5, then the lower limit is 1. For 6 to 10, the lower limit is 6. Okay, then this one is called as upper limit. So I'll write here as UL. Okay, so this one is UL also. Then this one is UL. This is UL also. Okay, so now you can see that for every of your class interval, right, normally it's not like 1 to 6, then 6 to 11. Like it's going to be have something like in the middle here. So for this middle, like what is the boundary actually separate 5 and 6? It's going to be 5.5. Okay, so what is this number called? 5.5 is going to be the lower, sorry, it's going to be the upper boundary for the class of 1 to 5. Is that okay? But at the same time, for the class 6 to 10, 5 to 5 is going to be the lower boundary. So meaning like the upper boundary for 1 to 5 is the same thing as the lower boundary for 6 to 10. So it's the same thing like here, I will have 10.5. So 10.5 is called as the upper boundary for 6 to 10 and is also called as the lower boundary for 11 to 15. So same thing, I have 15.5 here, then this is my UB, then this is my lower boundary. Okay, so what is the upper boundary for this one if it's going to end here? So 20, so you can see for the size between here is like plus 0.5. So I have a number here which is 20.5, which is the upper boundary for 15 to 20. So same thing here, if I have 5.5, so meaning here I can have a 0.5, which is the lower boundary for the class 1 to 5. Is that okay? So later when we are going to draw a histogram and cumulative frequency graph, right, you will need the boundary. So you need to know what is that mean by upper boundary, what is that mean by lower boundary. Okay, so basically it's like the number that actually separate your class, and then it's going to be the same for like as for the upper boundary for your class previously and the lower boundary for your class for your next class. Okay, so the same thing with the box and whisker diagram, you can actually use a histogram to check for the skewness also. So it's the same thing lah. So if you have something like this, which you can see the value that actually before your before the highest in the middle is, or like the median is like the equally same, then you have a symmetric distribution. So if you have like a longer tail to your left, meaning if you're going to draw a graph, right, it's going to be like a longer tail, then after that a shorter one. So this is called a negatively skewed. So for positively one, then it will be like a normal one, then after that you will have a longer tail at your right. So this is positively skewed. Okay, so you can try to read it out yourself also. So now we are going to move on to how to draw a histogram. Okay, so this is going to be like a quite easy one. So yeah, we'll just go through together. Okay, so this one, draw a histogram based on the table below and comment on the histogram. So what you can see is like 10 to 14, 15 to 19, 20 to 24. Okay, so maybe we find out what is the lower boundary and upper boundary first. Okay, so for this one, what is the lower boundary for, we find the middle first maybe. This is 14, then here is 15, then the boundary here is actually to be 14.5. Okay, so the same thing for here, then we have 19.5. Okay, so since it's like 0.5, 0.5, then I will have 24.5 here, and here is 9.5. Okay, so we need to find out what is the width or what is the interval size first. So you can realize when you use 14.5 minus 9.5, you get 5. 19.5 minus 40.5, you get 5 also. 24.5 minus 19.5, you get 5 also. So all the size here is like the same. So you see when the interval are of the equal width, then the height of the bar, you can straight away use your class frequency, which is this is your class frequency. So we do not need to make any changes of this. It's just like based on our raw data, then now you can start to draw your graph already. Okay, so I'm just going to like draw it, then you can draw it together. Okay, so for this side, for your y is always to be the frequency. Okay, so you can write down number of students, or you want to write down frequency also is totally fine. Okay, so since the max one is, I think is enough, let's do 10, 20, 30, 40, and 50. Okay, then after that, for your x-axis is going to be your boundary. Okay, normally we don't start with here, then we will like make it like make some space, then after that you can start to draw. Okay, so maybe here we try to do, since we have enough space here, then we draw a very big one. Okay, so 9.5, then you have 14.5, 19.5, and then 24.5. Okay, so don't forget here you need to write down age, years. Okay, then now you can start to draw 34, 46, and then 20. Okay, you must remember for histogram you don't have any space between your bar. It's not like your bar chart, okay? It's going to be like continuous. There's no space between your bar. So this is a histogram. Okay, finish. Is that alright? Yeah, I think it's quite easy, right? Okay, now we need to check on something. Okay, why is it when you have interval of equal width, your height of bar actually can represented by class frequency? Okay, so there's something in the histogram. You look at your first line. The area of each bar must be proportional to the frequency in the interval. So what does that mean? Okay, maybe look at this one. What is the area here? Okay, for your first bar, right, the difference here is like 9.5 to 14.5, so the difference here is like 5, correct? So 5, then your frequency here is like 34, so the area here is going to be like 3 times 34. So the same thing, we did it for this, so it's like 5 times your height here is 46. Then after that it's going to be 5 times 20. 5 times 20. So this is the, or we don't, okay, to not confuse you, I think maybe we use the box that we have here. Okay, instead of using 5, okay, maybe use 4, because we have like 1 box, 2 box, 3 box, 4 box. But the idea is the same lah. Okay, so when you have all this, right, and when you times the number, and now we try to put it in the proportion way. So for frequency, what's the frequency that you have? 34, 46, and 20. So what is the proportion here? If we use everything divided by 2, then you get actually 17, and then 23, and 5. And 10. Okay, everything divided by 3, I get the simplest proportion. When I change this, right, so like 16, 136, and then 24, 184, 4, then I get 80. So when I try to change all this in a simplest proportion, then what do I get? Okay, maybe all of this number I would need to divide by 8. Okay, so 80 divided by 8, I get 10. 184 divided by 8, I get 23. And then 136 divided by 8, I get 17. So you can see 17, 23, 10. 17, 23, 10. So it's going to be the same. So that's why the area of the bar is proportional to the frequency in the interval. So that's why you do not need to do the frequency density for this question, because like all the length here or all the width here is actually the same. So even though when you times with the area and when you change back to proportion, it's going to be the same proportion as your frequency also. So that's the idea, like why you do not need to change it to frequency density when you have all the class interval with the same size. Okay, but you just remember lah, if you don't understand this part, then you just remember for all interval that you have of the same size, then you do not need to change your frequency. So later we are going to look at the other one. Okay, so now let's move on for this one. Okay, so this one is the one that actually we need to change it. Okay, so the interval are not of the equal width. Okay, so maybe we check the boundary first, then you can understand what am I talking about. So 129 to 130, you get 129.5. And then here 139.5, 144.5, 149.5, 159.5, 169.5, and 119.5. Okay, so when you look at all this value, right, what you can realize here is the size now is different. So from 119 to 119.5 to 129.5, you have an interval of 10. 129.5 to 139.5, you also have an interval of 10. But 139.5 to 144.5 is going to be only 5. 144.5 to 149.5 is going to be 5 also. So that's why like all your size interval is different. So this is what is that mean by the interval are not of the equal width. Then now you need to change all your frequency into frequency density. So how to do that? Frequency divided by interval width. So we need to find out the interval width first. So 119.5 to 129.5, what is the internal width? Or sometimes we can use size also, it's the same thing, okay? So 119 to 129.5 is 10. 129.5 to 139.5 is 10 also. 139.5 to 144.5 is 5. Here's also 5. Then you have back to 10 and back to 10. So if you have all difference, if you do not have the same interval size, then we need to change it into frequency density. So how do you do that? So frequency density is going to be the frequency divided by the width. So 60 divided by 10, you get 6. 85 divided by 10, you get 8.5. 65 divided by 5, you get 13. 95 divided by 5, you get 19. 70 divided by 10, and then 55 divided by 10. Okay, so after you got all this value already, then now you can proceed with your histogram. So you remember now your y-axis is going to be frequency density, not frequency. Okay, so same thing. So when you write here, you need to write frequency density. Okay. Then for here it's going to be the height. Okay, then now you can try to write down your class. Okay, so this is 119.5, 10, so 129.5, 139.5, 149.5, 159.5, 169.5. Okay, then now you can start to plot. So you must remember it's a 10 here, so you might need the 144 later. You are going to plot in between. Okay, so we start with the 6 here. For 119.5 to 129.5 is going to be 6. Okay, we do this first. Since the max is at 19. Okay, so we start with the first one. We have 6 for 119.5 to 129.5. 6 is it? Okay, then after that 8.5. Okay, then the next one, you remember this is the 5 one, so it's from 139.5 to 144.5 only, so 13. Okay, then next one, 19, also a width of 5 only. Then after that 7. 6, 7. okay, and then 5.5. Oh yeah, it will be good if you can use pencil to draw your graph. I don't use my pencil here because I tried, but it seems like it is not so clear. If I use pencil, then you cannot see from the camera. So that's why I'm using black pen. So please use pencil, because if you make it wrong, then you can't like use correction tape or anything in your graph paper, right? So that's why I use pencil. Okay, so this is the graph. So when you check the proportion, right, then this is how you get it back. You like the difference here is like 2, so okay, maybe the 2 box, and then when you times 6, so area is like 2 times 6, and then here is going to be 2 times 8.5. Then this is 1, right? So 1 times 13, 1 times 19, and then here is going to be 2 times 7, 2 times 5.5, like 2 box here, then this is the height, like 5.5. So I get 12, and then 17, 13, 19, 14, and 11. So now let's check. So this is the, I cannot simplify already, right? So check with my frequency. So my frequency here is 60, 85, 65, 95, 70, and 55. So when I check this, I simplify all this number, right? Then what do I get? So when I simplify all this number, then I will be getting 12, 17, 18, 19, divides 13, 14, and then 11. So you can see this row and this row, like it's totally the same. So that's why for the area of each bar is proportion to the frequency in the interval. So that's why this is correct. Okay, so this is the idea. Why do you need to change it into frequency density when the size of the interval is different? Okay, so yeah, but this one is just like for your understanding lah. So in the exam, you do not need to do this part. It's just like you need to make sure that you know when do you need to change it to frequency density and when is the time that you do not need to do so. Okay, so that's it for histogram. Then we move on for the last part. Alright, let's finish this last part, cumulative frequency graph. Okay, so a cumulative frequency graph is constructed by plotting cumulative frequency against upper class boundary. So remember, cumulative frequency and upper class boundary. So you use, like for your x-axis, it will be your upper boundary, then for your y-axis is going to be cumulative frequency. So you have two types of like cumulative frequency graph. The first one is cumulative frequency polygon, then the second one is cumulative frequency curve. So there's no rule that telling you that you must do a polygon or you must do a curve. So basically in the exam, if they want you to draw a cumulative frequency graph, meaning both can be accepted. It's the same thing for your A-level exam also. Okay, so later we are going to try both, so you can see like which one you are more comfortable with and which one you prefer, then you can stick with that. Okay, so normally for a cumulative frequency graph, we can use to find out what is the median, what is the quartiles, and then how to find like the proportion or the percentage, like if you want to find a distribution below some specific number or like above some specific number. Okay, so we are looking at one question. So for all these questions, then we try to identify all this together, then you should be able to know how to do that already. Okay, so before we start, so let's try to copy the information first. Okay, so you can go through the example. The table shows the length for 80 leaves from a particular tree given to the nearest centimeter. Draw a cumulative frequency curve and a cumulative polygon. Use each of these to estimate your median, your interquartile range, and the number of the leaf, blah 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 blah, and so on. Okay, so let's try to draw the curve and the polygon first. Okay, so for this one, then what do you need? You need to find out what is your cumulative frequency and what is your upper boundary first. Okay, so before that, you must remember your cumulative frequency must be always start from 0 when you draw a cumulative frequency graph. So that's why for your first upper boundary, the first line, we leave it blank first because you don't have anything that actually contribute a cumulative frequency of 0. So we will write this at the second column and so on. So 1 to 2, I'm just copy 3 to 4, 5 to 7, 8 to 9, 10 to 11. Okay, my frequency 8, 20, 38, 10, and 4. Okay, then what is the upper boundary? So 1 to 2 and 3 to 4, so the upper boundary is 2.5. So upper boundary for 4, 4.5, 7.5, 9.5, and 11.5. So what is the next value here, like the lower boundary of 1 to 2? So it's going to be 0.5. Okay, so this one you just leave it blank because you don't have anything, so that's why the cumulative frequency is 0. So how to find the next one? 0 plus 8, 8, 8 plus 20, 28, 28 plus 38, 66, 66 plus 10, 76, 76 plus 4, 80. Okay, so I think I explained about cumulative frequency before also. So it's basically like I have 28 leaves that has a length of 4 centimeter or below. So 66 meaning I have leaf that has a length of 7 or below. So 80 of like everything, like all my leaves having a length 11 centimeter and below. So this is what is that mean by cumulative frequency. Okay, so after we find this, then we can now try to draw our graph. So the same thing, if you can, then please try to use pencil instead of pen, because yeah, if you make it wrong, then it will be very hard for you to change. Okay, so let's start with cumulative frequency polygon. So actually for both you are doing the exactly same step. It's just that when you connect the curve, then you are using different line. So for polygon you are using a straight line, for frequency curve you are using a curve. That's it. Okay, so I'm just going to like plot the points like very quickly, because yeah, I think you should able to understand what I'm doing. So it's like very common sense lah, so I do not need to explain much. Okay, so yeah, you just remember this must be cumulative frequency. Okay, so it cannot be frequency, must be cumulative. Okay, 2, 4, 6, 8, 10, 12. I hope it's not too small from the camera though. Okay, so 10, 20, 30, 40, 50, 60, 70, 80. Okay, then after that you can try to plot every of your point. So 0.5 is 0, so this is 2, this is 1, so 0.5 is 0. Okay, then after that move on. 2.5 you have 8. 8. Okay, then 4.5 you have 20. Then 7.5, 38. Next one, 9.5 is... Do I do anything wrong? Yes, I did. Oh no. I'm so sorry. I hope that you are using pencil. Okay, so you see, I used the frequency instead of. So this is going to be this is wrong, okay? So this is going to be 28. And then the next one, 66. 7.5 is 66. Okay, then the next one, 76 for 9.5. 80 for 11.5. Okay, so I'm going to connect to the correct line, so yeah, just ignore the part that I did it wrong. Is that okay? So this is frequency polygon, meaning you use straight line to actually connect all the lines. So for the straight line one, we call it as cumulative frequency polygon. So for the next one will be cumulative frequency curve. You are going to draw the exactly same thing, but now it's going to be a curve. Okay. So yeah. Okay, same thing lah, cumulative frequency, I write CF here. Okay, then after that, same thing, try to plot it. Remember cumulative frequency, 0.5, 8, 28, 66. And then 76. D. Okay, so after this, for this one, it's going to be cumulative frequency curve. So meaning you should use free hand to draw a curve. Okay, so I'm sorry, I actually need to turn my paper, but I okay, so this is how you draw a curve. Is that alright? Yeah, so you can turn your paper around if you feel like it's very hard for you to draw. So this is basically like a smooth curve. So this is called cumulative frequency curve. Okay, so the first one, cumulative frequency polygon. Second one is curve. So it's like the same thing, but then one you are using curve, the other one you are using polygon. So now we continue with answering the question. So I'll do for the first part, then after that I'll give you answer for the curve, then you can check it by yourself, okay? Alright, so for the first one, find the median. So you still remember for the median, we'll use the whole number then divide by 2, right? So we do it for the same. So for A part, to find median, okay, so the total number here, you check for your cumulative frequency, it will be 80. So 80 divided by 2. So it will be the 40 value. So how do you check that? Then you use your pencil, then at the 40 there, then you draw a dotted line. Okay, reach the graph, then after that you drop it down to your x-axis. I'm sorry because I cannot move my paper nearer to me, so I guess I might doing like a little bit, yeah. Okay, so but then yeah, I'm getting the answer 4.5. Okay, so this will be my median. So let's write down the here side the length cm. So this is like the length cm also for your curve. Okay, so 4.5 cm. Okay, for B, then you need to find what is the interquartile range. So interquartile range, you need to find Q1 and Q3. So Q1 is basically 80 divided by 2. So it's the 20th value. Okay, so you do the same thing from the 20 for your cumulative frequency, then you drop to your x-axis. Is that okay? Yeah, so you should be getting 3.7. Sorry, the line is not like very straight, so yeah. 3.7 cm or like 3.6 also can be okay. Okay, now after that Q3, it will be 80 times 3 divided by 4. So you have the 60 value. So you draw the same thing from 60, a dotted line to your graph. Sorry, I know my line is a bit off. Yeah. Okay, I think you will get like 7. Okay, so IQR equals to Q3 minus Q1, which is 7 minus 3.7, which will give you 3.3. Okay, so let's move on to C. So find the number of the leaves that is less than 3.7. Okay, number of leaf less than 3.7. So what do you need to do is the 3.7 here. Then after that you draw it. I think for this one is like yeah, the 3.7 is exactly the line that you actually have drawn just now. So 3.7 is actually 20. Okay, let's change this in your question. So yeah, I'm going to change it in your paper, don't worry. So change it to 6 maybe. Okay, number of leaves that are less than 6 centimeter long. So what do we need to do is at the 6 centimeter, oops, then we need to draw a line. Okay, to the graph. So 6, then we draw the dotted line. Okay, so now you need to read how many number is that. Okay, I think you are getting 46. Let me check again. Yeah, 47 to be exact. Okay, so yeah, I think this one it should be a little bit up. Yeah. Okay, so this is how you find it. So like from 6, then you find the number, then you draw it there, then you got 47. So meaning like there are 47 leaves that actually has a length of less than 6 meter. Okay, so D, the percentage of the leaf that are more than 9 centimeter. So this is something that you need to be careful of. So when you all your cumulative frequency tells you like below, so meaning like I have 66 here. Is like 66 of my leaf having a length that is less than 7. So the number here didn't tell me anything more than. So when you need to find the number, then meaning if I have 66 leaves less than 7, meaning more than that, then I will need to use 80 minus 66. Then I need to do the same thing here. So the percentage of the leaf that are more than 9 cm, that means that I will need to draw my 9 cm first. Okay, can you try to draw a dotted line by yourself? Yeah, it's like very hard for me to draw. Okay, I think you will be getting 74 for this value. Okay, so after you get that, meaning that 74 leaves actually has a height less than 9 cm. So for more than 9 cm, then what do you need to do? It's going to be this value only. So that's why 80 minus 74, then you get 6. Then this question want to find out the percentage. So 6 over 80 times 100%, then you get 7.5%. So 7.5% of the leaves has the length more than 9 cm. So like less than you have 74, more than you have 6. Okay, then E, the last one, the lower boundary of the length of the longest 22 leaf. Okay, so longest 22 leaf, meaning I want to find what is the lower boundary for the length for my maximum value, like maximum the 22 maximum value. So meaning if I have 80 as a whole, so meaning minus 22, then I will be getting 58. So I need to check out like for 58 what is the value, then I can know that what is the lower boundary for the length for the longest 22 leaf. So meaning I'm finding the longest 22 leaf, what is the minimum value of the 22 leaf. Does that make sense? Okay, if I am going to draw 22 here, right, meaning I'm finding like what is the maximum for the 22 leaf, the shortest 22 leaves. So now I want to find 22 longest, meaning it's like the the longest 22, meaning like I have 58 leaves actually shorter than the 22. So that's why I'm doing like 80 minus 22 giving me 58. Okay, so lower boundary, then I need to draw at 58. So same thing, you try to draw at 58, then draw it down. Okay, then you shall be getting 6.8. Okay, try to check it out yourself. So the lower boundary for leaves here is going to be 6.8. So the 6.8 cm here actually tells you that for the longest 22 leaf, the minimum, like the shortest one within the longest 22 leaf is going to be 6.8. So anything lower than 6.8 is not in the 22 longest leaves. Yeah. Okay, so I'm going to write down the answer for the curve one. So when you do it, right, you can realize that the answer will be slightly different, but in your exam it's going to be, they will have a certain range for your answer. So don't worry about that as long as your answer is like not too different than the exact answer. Okay, so I'm going to write down. I think the last two is actually still quite similar. Okay, so you try to check it out. Okay, I write down the answer here. So I hope that you have no problem with this. Yeah, actually it's actually quite easy. It's going to be like understanding and common sense only. Okay, so today lecture will be pretty short, and I think for the homework wise, I'm just going to give out like few past year questions. So hopefully you can have a, because I guess like last week we have quite a packed schedule or quite a long lecture, so that's why we can be a little bit chill for this week. Okay, so hope you get everything today, and thanks for watching.